Hello everyone, myself Tumpa, Assistant Professor, Department of Chemistry, Darrang College. Today I am going to discuss about types of electronic effects. So these electronic effects help in explain the acidity and basicity of organic compounds. So there are mainly four types of electric effects. One of them is inductive effect. So what is inductive effect? Inductive effect is the displacement of the sigma electrons towards the more electronegative atom. So whenever there is a electronegativity difference between two atoms, then the shared pair electron, that mainly the sigma electrons, move towards the more electronegative atom. So here you see carbon and chlorine. So chlorine is more electronegative than carbon. So what happens? The sigma electrons shifted more towards the chlorine atom, and therefore there is a development of a partial negative charge on the chlorine atom and partial positive charge on the carbon atom. So whenever there is a electronegativity difference, then inductive effect arises. So what we can say that inductive effect is the phenomenon of transformation of charge due to electronegativity difference through a chain of carbon atoms by sigma bonds. So here you see with increase in the distance, so carbon, so in the fourth carbon you see, so the fourth carbon is away from the more electronegative atom. So with increase in the distance, the inductive effect decreases. So depending on the groups, there are two types of inductive effect. So one is minus I effect. So when the atom attached to the carbon atom is more electronegative than the carbon atom, then carbon pushes the electron towards the more electronegative atom, or we can say that the more electronegative atom takes away the sigma electron more towards itself. So this effect is known as minus I effect. The shifting of the sigma electrons away from the carbon atom is known as the minus I effect, and the group which attracts the electron towards itself, they are known as minus I group. For example, bromine, chlorine, nitro, then hydroxyl group, methoxy group. So these are the groups which show minus I effect. Another is plus I effect. So when the shifting of the sigma electrons takes place towards the carbon atom, or that means when carbon is attached to a less electronegative atom, then the inductive effect is known as plus I effect, and the groups are said to be plus I groups. So mostly the alkyl group, then aryl group, and the metal atoms that are less electronegative than carbon, they mainly shows the plus I effect. So inductive effect has the following characteristic. So it is a permanent effect. So I have already said that whenever there is a electronegativity difference, then the inductive effect arises. So it is a permanent effect. And it operates through sigma bonds. Only the sigma electrons, displacement of the sigma electrons takes place. Its magnitude goes on decreasing with increase in the distance from the atom or group responsible for the same. So therefore what we have said that inductive effect is negligible for the third and the fourth carbon atom. Minus I effect of some groups is in the order. So this is the order of minus I group. So here we can see that quaternary ammonium salt have more minus I effect than nitro group, than cyanide, carboxylic, fluorine, chlorine, bromine, iodine, hydroxyl, methoxy, phenyl, and hydrogen. As nitrogen acquires a partial positive charge and nitrogen is more electronegative than carbon, therefore it have a more tendency to attract the shared pair electron more towards itself, and therefore it has high minus I effect. So similarly, the groups having the plus I effect have the following order. So here is the carboxylate ion, then tertiary alkyl group, dialkyl group, monoalkyl group, then methyl, deuterium, hydrogen. So here in this there is a negative charge, and therefore due to the presence of this negative charge, it push electron towards the towards the carbon atom. So this is the order of the plus I effect. So some groups having the plus I group or the minus I group, they may be neutral. So here the minus I effect group having atom oxygen, nitrogen, sulfur, halogen, then carbon-carbon double bond, carbon-carbon triple bond. They do not have charge, but they show minus I effect, whereas in plus I effect like hydrogen, magnesium, so they have no charge but they show plus I effect. Then charge group like ammonium ion having a positive charge, they show minus I effect, and if the carry minus negative charge, then they show plus I effect. So next effect is electromeric effect. So electromeric effect is a temporary effect. So it needs pi electron. This is the shifting of the pi electron. So here we need carbon-carbon multiple bonds. And there is a demand of an attacking reagent. So when we remove the attacking reagent, the electromeric effect disappears. So it is a temporary effect. So I've already said that it's shown by the compound containing multiple bond and highly temporary. So like inductive effect, electromeric effect are of two types. First is Placid effect, when displacement of the electron is away from the atom or group. So here we see that in presence of the acid, so this is proton, the shifting of the electron is away from the carbon atom. So this is known as Placid effect. And due to this, there is a positive charge on the carbon atom. So when we remove this proton, there is no electromeric effect. So another is minus A effect, when the displacement of electron is towards the carbon atom or group, towards the atom or group. So here we see that in presence of cyanide ion, the electron displacement takes place towards the oxygen atom. So this is known as minus E effect. Third one is mesomeric or resonance effect. So mesomeric or resonance effect takes place when there is a conjugation of bond. That means double bond or single bond, or for example 1,3-butadiene, there is a double bond conjugation. So here we see that double bond, single bond, then again double bond. So whenever there is a conjugation of double bond and single bond, they undergoes mesomeric or resonance effect. Another is if this is the orbital diagram of the 1,3-butadiene molecule. So similarly, if there is a conjugation between double bond and a lone pair electron, double bond, single bond and a lone pair electron, then they also show resonance or mesomeric effect. So here this is the vinyl chloride. So there is a double bond, single bond and lone pair electron. So this type of molecule also undergo mesomeric or resonance effect. Now what is resonance? So resonance is that when a single structure of the molecule couldn't explain all the properties of the compound, and we have to draw more than one structure to explain all the properties, then that phenomenon is known as resonance effect. So each contributing structure doesn't explain all the properties of the structure, but the actual structure, that is the hybrid structure, explain all the properties, and hybrid structure is the contribution of all this structure. And these properties are explained by Robinson and Ingold and gave the concept of mesomerism, and which was developed by Pauling, modified and developed by Pauling as the theory of resonance. So here this is the resonating structure of vinyl chloride. So here we see that chlorine have lone pair electrons. So chlorine donates electron towards the carbon atom, and the pi electron shifted towards the next carbon atom. So there is a development of negative charge on the carbon atom. As chlorine donates the electron, so chlorine develops a positive charge. So this have lone pair electron, and this type of known as plus-m effect. When the atom donates electron towards the carbon atom, then this type of effect is known as plus-m or plus-r effect. So we consider the nitro group conjugated system. Here we see that oxygen is more electronegative than nitrogen. So oxygen withdraws electron and nitrogen have positive charge. So it withdraws electron from the pi electron, and therefore there is a positive charge on the carbon atom, whereas oxygen gets a negative charge. So here the nitrogen atom withdraws electron from the carbon atom, and this type of effect is known as minus M or minus R effect. So where there is a lone pair electron, they mainly show plus R effect, and when there is a positive charge on the central atom, they mainly show minus M effect or minus R effect. So these are the groups which show plus M or plus R effect: ammonia, amine, hydroxyl group, methoxy group. So every here the central atom has a lone pair electron, and this type of molecule show minus M or minus R effect. So that we see here that there is a positive charge. So when the central atom acquires a positive charge, they mainly show minus M or minus R effect. And if there is a multiple bond, double or triple bond, like in aldehyde, cyanide, in aldehyde carbon oxygen have double bond, in cyanide carbon nitrogen has triple bond. So whenever there is a double bond or triple bond, they also show minus M or minus R effect. So here this is chlorobenzene. Here we see the plus M or plus R effects. Chlorine donates electron towards the ring. So chlorine gets a positive charge, whereas the ring carbon gets negative charge. So we can take another example of plus M or plus R effect with the hydroxyl group phenol. So here also oxygen has lone pair electrons, it donates electron towards the ring, and therefore oxygen acquires positive charge, whereas the ring carbon acquires negative charge. Next effect is hyperconjugation. Hyperconjugation is the donation of sigma bond into an adjacent empty or partially filled p orbital, which results in an increased stability of the molecule. So this is the donation of the sigma electron, not all the sigma electron, but the sigma electron of carbon and hydrogen bond. So here we see that carbon hydrogen bond, this sigma electron is shifted to the nearest carbon-carbon empty orbital. So there must be multiple bond in, and also there should be, the carbon should have an empty orbital to which the sigma electrons can be shifted. So this is the orbital diagram. So this there is no bond of the, between carbon and hydrogen, because this is shifted to the empty orbital of the nearest carbon atom. So it is developed by Becker and Nathan effect, and after the donation of the sigma electron, as there is no bond between carbon and hydrogen, therefore this effect is also known as no bond resonance effect. So from through hyperconjugation, we can explain the stability of the carbocation. So here we see that according to the rule, more the hyperconjugation, more is the stability. So as the number of carbon hydrogen bond here in tertiary carbocation is more, so there are 9 hyperconjugable hydrogen, therefore it is more stable because more hyperconjugation is there. In case of secondary carbocation, there are 6 hyperconjugable hydrogen, which is lesser than the tertiary carbocation, and therefore secondary carbocation is less stable than tertiary, which is less stable than primary, because there are only 3 hyperconjugable hydrogen atom, and in methyl there is no hyperconjugable hydrogen atom. So the stability of carbocation can be explained with the help of hyperconjugation. So next, let's talk about the application of inductive effect. I have already initially said that we can explain the acidity and basicity of some organic molecules by this effect, by mainly the inductive effect. So how? So suppose this, in case of acid, formic acid is stronger acid than methanoic acid, which is more stronger acid than propanoic acid. Why? Because with increase in the number of plus I group, acidity decreases. So in case of methanoic acid, there is 1 plus I group. In propanoic acid, there are 2 plus I group, but in formic acid, there is no plus I group. So therefore, formic acid is more stronger acid than the other 2 acids. So with increase in the number of plus I group, acidity decreases. Whereas here we see the nitro group, fluorine, chlorine, there are minus I group. So when the acidity increases with increase in the number of minus I group and also the strength of the minus I effect. So as we know that nitro group has more minus I effect than fluorine, chlorine. So therefore nitroethanoic acid is more stronger acid than fluoroethanoic acid, than chloroethanoic acid, than bromo, iodo, and methanoic acid. So what we have learned that presence of plus I group decreases acidity and presence of minus I group increases acidity. Similarly, we can also explain the relative basic strength of amines through inductive effect. So for example, methylamine is more basic than ammonia. In methylamine, there is a plus I group, whereas in ammonia, there is no any plus I group. So what we can say that presence of plus I group increases basicity, because it increases the electron density on the nitrogen atom. Therefore, basicity increases. Again, aniline is a weaker base than ammonia, because in aniline there is a alkyl aryl group, and aryl group is a minus I group. So it withdraws electron from the nitrogen atom, and therefore its basicity decreases as compared to ammonia, where there is no any -I group. So the basicity, acidity, that can be explained with the help of inductive effect. So all these effects explain the stability, then acidity, basicity, and other properties of organic compounds. So this is all for today. Thank you very much.